Let us proceed with our discussions on strain gauge. In our previous videos, we talked about strain. We mentioned that it is a form of deformations or a measure to quantify deformations. So what is strain actually? First, when a material is subjected to external forces, for example this one, a pulling force P is applied to the material. The force here will generate stress over the cross sections of the material. The equations for the stress is this, which is the force applied to the material divided by the area of the material, assuming the force is equally distributed throughout the cross-sectional area. Now, when the material is subjected to stress, it undergoes deformations. The pulling force will cause the materials to elongate slightly. While elongating, due to the Poisson ratio, the material becomes thinner. Now, the original length is the L. The elongation is considered as delta L. Under tension, the new length now it will be L plus delta L. The material now is slightly longer than the original. For us to quantify the strength, we are dividing the delta L with the original length. In another word, the strength here is a ratio which does not have unit. L can be in terms of the mm, millimeter, and delta L also in millimeter. If you divide delta L with L, the units cancel out each other. So it is a unitless ratio, and it represents the percentage of elongations with respect to the original length. The same concept applies to the compression. Now, if you apply forces compressing the material, the original length is L. Under compression, the material shortens. Now, the new length it will be the L minus delta L. Now, for you to quantify the strength, you are quantifying the ratio between the shortening length and the original length, which is delta L per L. The negative value here represents shortening of the member. So, if you see negative sign for the strength, you know that it is undergoing compression. Now that we know the strength, let us talk about the strain gauge. What is the concept governing the strain gauge? The first thing you need to know about strain gauge is that it is an electrical instrument. You have micro wire or electrical resistant foil on top of the strain gauge. And this wire is placed on the strain gauge. Its function is to form a circuit, allow currents to go through it. These wire or foil are very thin, which can easily be damaged. So when you want to use it, you have to use it carefully. Going back to the fundamental, because of the thin line of the wire or the foil, there will be electric resistance. Now the deformations of these wires will lead to the changes of this electric resistance. The electric resistance of a metal, in this case, is referring to the wire and the foil, changes proportionally to the mechanical deformations caused by the external force. To make it simple, if the strain gauge is subjected to the tension, the electric foil or wire will elongate. Having the wires to be elongated, due to the Poisson ratio, the wire elongated which at the same time the cross-sectional area reduces. Now, having smaller cross-sectional area, you will have higher electric resistance. In contrast, if the strain gauge is subjected to compression, it becomes shorter and fatter. The electric wires or foil will undergo compressions. It strings longitudinally and it goes sideways in the lateral expansion. This leads to a larger cross-sectional area. And when the cross-sectional area of the wire increases, the electric resistance reduces. Now the concept is this. Under the normal conditions, the strain gauge itself has an existing electric resistance. Now when the strain gauge is subjected to tension, the cross-sectional area reduces, the resistance increases. If you are able to quantify the electric resistance, since the relationship is proportional to the deformation, you are able to quantify the strength. Now, if the strain gauge is undergoing compression, the wire becomes shorter and fatter. The resistance reduces. By quantifying the reductions in terms of the electric resistance, knowing the proportional relationship with the mechanical deformations, you are able to quantify the strength also. This is at the context of the strain gauge. Now this strain gauge here will need to be properly installed onto the materials that you want to measure. You need to ensure good bond with the strain gauge so that whatever deformations of the materials that you are measuring will be equivalent to the deformations undergone by the strain gauge, as the readings given by the strain gauge is actually measuring the electrical resistance that reflects the deformations of the strain gauge itself instead of the material. It is only when the deformations of the strain gauge is same as the deformations of the material, then the reading given by the strain gauge shall be considered the deformations of the material. Since the whole thing here is based on electric current, the materials that you are measuring may also conduct current. This is going to affect the results in the strain gauge. Therefore, it is important to ensure the strain gauge to be insulated from the materials so that the result is not disturbed. Therefore, these wires or electric foil shall be laid on a thin layer of electrical insulator, and this electrical insulator shall be pasted onto the materials that you intend to measure. Place the strain gauge in the right locations to measure the regional deformations. You cannot allow the direct contact between the electric foil or the wire with the material. Now, if the strain gauge is properly bond with the material, whichever deformations undergone by the material shall be effectively transferred to the strain gauge, and therefore strain gauge is also undergoing the same deformations. Whichever measurements as acquired from the strain gauge will represent the conditions of the material. Simply said, the strain gauge is a sensor, and it is measuring the strength by the means of measuring the electric resistance change. This can be further explained by using the diagram here. First, you have a material that you wish to test. You are actually applying the force onto the material that you wish to test, and because of the force applied to the material, be it tension or compression, the material will undergo deformations. Now, the deformations can be very small, which cannot be easily detected through naked eyes. or sometimes the deformations is too small that it cannot be measured by rulers or measuring tapes. We want the accuracy of the measurement. Then we can adopt the strain gauge. The strain gauge is attached to the material. Make sure it is properly bonded and make sure it is properly insulated. Now, if the materials is properly bonded, the deformations of the materials that you are testing should theoretically be the same as the deformations undergone by the strain gauge. Because of the deformations, the cross-sectional area of the wires or the electric foil on the strain gauge changes, and this leads to the changes of electric resistance when the current passing through the strain gauge. So what you are doing here is you are measuring the electric resistance. You are quantifying the changes of the electric resistance. Based on the result here, you are computing the deformations of the strain gauge. And these deformations of the strain gauge is assumed to be same as the deformations of the material where the strain gauge is attached to. Ultimately, the strain gauge is a tool for you to measure the deformations of a material when subjected to force. Now let us proceed with our discussions with the principles of strain gauge. We have mentioned about the relationship between the strain gauge and the tested material. We also mentioned that we are quantifying the changes of electric resistance in order to determine the deformations of the strain gauge. Now, how do we quantify the strength? It is based on the gauge factor. We assume the strength of the material will be same as the strength of the strain gauge. And we also assume that the electrical resistance change proportionally to the mechanical deformations of the strain gauge. Now, when we want to quantify the strength, we are quantifying the mechanical deformations of the strain gauge or the material. It is by dividing the changes of the length over the original length. Now, the changes of the length will cause changes in terms of the cross-sectional area, and this shall change the electrical resistance of the wire. Since the relationship is proportional to the mechanical deformation, now the changes of the resistance can also be divided in respect to the original resistance. Now the next problem here is, how do you correlate the mechanical deformations with the electrical resistance? We will require a factor which is known as the gauge factor. This is the factor that you need to key in the data logger so that the data logger can help you to compute the strength measured by the strain gauge. Now, where can you get the gauge factor? Normally, it is shown on the gauge package. Taking this as an example, the specifications is given here. The gauge factor is given here. This will be the factors that you use to key in to the data logger in order to display the strength.